Conditional probability means you have this probability given a certain condition or given a certain population. This line right here, you can read that as given. So I would read this as the probability of B given A happened. Okay? So what's the difference between what we've been doing and what does given mean? So if you look at this two-way table, right, and this is called a two-way table because you read it two ways. You can read it horizontally, who has a high school diploma, yes or no, and you can read it vertically, who has experience, yes or no. Okay, that's called a two-way table. Okay, if I just have a probability question, what's the probability that someone has a diploma? You're saying favorable over total. Out of all of my job applicants, who has a diploma? So the first thing I would have to do is consider how many total job applicants are there. So you add up all four numbers and get what? We add them all up and get 90 total job applicants. So of these 90 job applicants, what's the probability someone has diploma? So you look at has diploma, yes, add those two numbers up, right? These are all the people that have a diploma. 81. So 81 people of the 90 has a high school diploma. There's your probability. So you take 81 divided by 90, and what's that as a decimal? 0.9. Good. What's the probability that someone has a diploma and experience? So again, out of everybody, out of all 90 people, how many people are both diploma and experience?
54.
Yep, diploma and experience, 54. So 54 out of 90, which is what is a decimal?
0.6.
Good. Okay, so what's different now with the given is that I'm not considering out of all 90 people anymore. I'm going to have a certain given population. What's the probability that someone has experience given that they have a diploma? So I have to change this. My given now is has a diploma. So here's the people that have a diploma, and we said that's 81, right? So out of these 81 people, my given, what's the probability out of just these 81 people that someone has experience? 54 out of the 81. What's that as a percent or decimal? 0.67? What's the probability that has no diploma given that they have experience? So now my given is this. Given that they have experience, so that's 59 people. So given that they have experience, what's the probability that they have no high school diploma? So 5 out of 59, which is what is a decimal? 0.08. Good. Second example of two-way table. This one I'm talking about number of degree recipients, right? And they're either male or female. And the other thing I'm looking at is associates or bachelors. Okay? So the first question asks, what's the probability the recipient is male? So out of all my recipients, which is what?
A lot.
2,134. So out of 2,134 recipients, what's the probability that they're male? So I look, okay, who's male? How many total are male here? 843. So I would take 843 divided by 2,134, which is what is a decimal?
0.395.
Point what?
0.395.
0.39, so 0.4. Good. How about the degree is a bachelor's? So again, out of everybody, right? I want the probability the degree is a bachelor's, so I need to add those two numbers together, which is what?
1,456.
Okay, so I take 1,456 divided by 2,134 and get what is a decimal? 0.68. Good. Okay, now let's change it. Now let's, instead of the line, it has the word given, but it means the same thing. You can see it both ways, either with that line or the word given. So this one says, What's the probability the recipient is female given that the degree is associates? So now my given population is associates, right? And I already have that. What is it? Add those together. What is it?
678.
So out of the 678 people with associate's degree, what's the probability the recipient is female? So 433 divided by 678. See how my total changed because of the given? What's that as a decimal? 0.64. Good. How about the degree is not an associate's given that the recipient is male? So now my given is male. So out of the males, which was what? 843? So out of the 843 males, what's the probability the degree is not associates? So bachelors, right? So 598 over 843. What's that as a decimal?
0.71.
Good. We can look at given conditions is just with percents. Okay, so if you read all four of these percents, okay, and then you look over here at the question, and again we're going to do favorable over total. Find the probability that a respondent has a pet given that the respondent has had a pet. So the first thing we need on the bottom of our fractions here is that respondent has had a pet. What percent has had a pet? 86%. So that's on the bottom because that's my total. That's my given. Now, what's my favorable? Respondent has a pet given that they had a pet. So that's your 39% that meet both. That's my favorable. So favorable over total, what is that as a percent? Or as a decimal? 0.45. Good. Okay, let's try another one. The probability that a respondent has never had a pet given that the respondent does not have a pet now. So we have to find the given first. What percent does not have a pet now? 61%. That's on the bottom. And the favorable is on top. What's the favorable? Has never had a pet and does not have a pet now. 14%. Very good. So what's that as a decimal? Was it? 0.23. Good.
Doubt myself.
Okay, this last part is conditional probability with tree diagrams. How you set up a tree diagrams is you consider what event has to happen first, followed by what event happens second. Okay? So the football team has a 70% chance of winning when it doesn't snow, but only a 40% chance of winning when it does snow. Suppose there's a 50% chance of snow. Make a tree diagram to find the probability that the team will win. So if I'm going to make a tree diagram, what event is going to happen first? It snows or doesn't snow. Very good.
Yeah.
So snow or doesn't snow, and you can use this little tally. That means not snow. Or you can say NS, no snow. Then after snow or no snow, then what event am I considering?
Win.
Win or lose. Very good. Win, lose. Win, lose. Okay, now I can fill in some percents. What's the percent of snow?
50.
So what's the percent of no snow?
50.
50. Yep, branch probability is always equal 100%. Okay? If it snows, what's the probability of winning?
70. Oh, if it does, 40.
Yep, 40% chance of winning when it snows. So this is 40, so what's my probability of losing? 60. Yep. What's my probability of winning if it doesn't snow? 70. So what's the probability of losing? 30. Very good. Now this is what I want. I want the probability the team will win. So I want snow and win or no snow and win. See how I have both ands and ors in that statement? So I want snow and wind. Snow and win. So I would multiply, right? Snow and wind. Or I can have no snow and a wind. So that, again, would be multiplying. And means multiply. So you have an or statement with and statements. And what's that? So 55% chance that we'll win. Good. Okay, so this one, again, we're going to set up a tree diagram, and there's two probabilities we're going to find. We're going to find the probability female is left-handed, and we're going to find the probability that both the male is a male and right-handed. Notice this second one has the word and in it. Okay, that makes a difference. All right, so we need to set up a tree diagram. If I set up a tree diagram, and I'm looking at males and females, left-handed, right-handed, which branch am I doing first? I walk into a room and I notice what first? Gender, male or female. Okay? Then I look at the males and consider left or right. The females, left or right. Okay? So I can fill this out. Of all the respondents, 17% are male. So if 17% are male, what percent is female? 83. Yep. Of the male respondents, 33% are left-handed. So if 33% are left-handed, what percent is right? 67. Very good. Of the female respondents, 90% are right-handed. So what percent is left? 10. Very good. Okay. So when you're answering these probabilities, see how this one doesn't have an and in it? What's the probability a female respondent is left-handed? I can just look at my tree diagram and tell you. Probability that a female is left-handed is what? 10%. Female left-handed, 10%. Okay? But the second one, I have an and. I want male and right-handed. Male and right-handed. And means multiply. So male and right-handed is what? 0.11? 11%. Good. Okay? Because of that, careful that and. And means multiply, or means add.